You're just adding by what? What'd you say?
4.
4. Plus 4, plus 4, plus 4, plus 4. So our pattern is we're adding 4. What would the next 4 numbers be? Gabby? 33, 37, 41, and 45. Okay? So all we're doing today is we're looking at sequences. We're going to figure out the pattern, and we're going to use that pattern to figure out the next terms in the sequence. Okay? But we're going to be able to do it no matter what term they want to ask us. So we could take this sequence, and they could ask us what would be the 116th term, and we would be able to figure it out. Okay? All right. What we call those sequences is we call them arithmetic sequences, okay? Now, what arithmetic means is it just means you're either adding or you're subtracting. You cannot multiply or divide for arithmetic sequences. So write down it's either adding or subtracting. Okay? So if our sequence was 2, 4, 8, 16, 32, okay? Notice how we're multiplying each term by 2 to get the next term. That would be an example of something that's not arithmetic. Okay? What's up, JJ?
Can you zoom out and go back to the warm up? I think I wrote something wrong.
Nope. Okay, so a sequence is an ordered list of numbers. Okay? So for example, we have the first position, which is 5, second position, which is 10, third position, which is 15, so on and so forth. Each number in a sequence is called a term. Okay? So each of those things in the sequence is a term. So 5 is a term, 10 is a term, 15 is a term. And each term has a specific position in the sequence, okay? So a sub n, where n is its position. The first number is your first position. So we label this 5, a sub 1. And that just means a with a little 1 as its subscript. The second position is a sub 2. The third position is a sub 3. The fourth position would be a sub 4. And the fifth position would be a sub 5. And we could continue that on for infinity. So we could find any n value and say a sub n for any value then. Yes, Mina?
This is counting by 5s, or we was dividing that way?
Yeah, very good. Now, the other thing to notice is there is a pattern, Amina, and you just said we're counting by 5s, right? So each time we're adding 5 here. So I want you to put plus 5 in between each of the terms, okay? And for a sequence to be arithmetic, it needs to have a consistent increase or decrease, okay? Do you see how every single time we were adding 5? If any of those were plus 6 and were different than the other ones, it would not be arithmetic. It needs to be consistent and it needs to be the same, okay? So circle any of those plus 5s and just draw a little arrow. We call that plus 5 our common difference. Okay? So each value that we increased by, as long as it's the same, then we know it's arithmetic, and that same difference is the common difference, okay? Now, if it wasn't common, if it wasn't all the same, then it wouldn't even be arithmetic. We wouldn't have a common difference, okay? But all arithmetic sequences will have a common difference, all right? Now, there is another term that we don't see, but it's a sub 0, and it belongs right here to the left of a sub 1. Now, keep in mind, it lies to the left of a sub 1, so instead of adding 5 to get to a sub 0, what do you think we're going to do? Subtract 5. So what's 5 minus 5? 0. So a sub 0, we got there by subtracting 5, is going to be 0. Okay? Will it always be 0? No. Okay? It depends on the sequence. All right? Questions so far? Yeah, Carson?
So, like, would it still be, like, going up by the same amount even if it's, like, negative? Like, it's the same number, but it's
Yes. Yeah, we're going to see that in one of the examples. That's a great question, okay? Are we testing on this? Oh, of course. Yeah. Yeah, it's going to be easy, okay? Now, The only difficult part about this lesson, okay, I need your full attention right now, okay, is the equation that we use, okay? So we say A sub n, which means any value of n, we're going to be able to find any position, is equal to D times n plus A sub 0. Now, this equation right above it is directly related to y equals mx plus b, okay? Now, m, which is our slope, is being replaced by this letter d, okay? So we're going to highlight those using the same color. This m is being replaced by d. M in slope-intercept form is our slope, right? But now it's d, and d in this expression is our common difference. Okay? It's the common difference. Yep.
Oh, for the A, is that an O or a degree sign?
That's just a 0.
Oh,
It's a sub 0 is what we call it.
okay.
Okay? Now, for the sequence that we just talked about, what would our common difference, what would our D be? Pedro? 5, very good. Plus 5 or 5, okay? So the common difference for our example would be 5. Now, n is the position of your term. So n we're just going to leave as n because we want to use that to be able to calculate any term that we want. But a sub 0 we should know. And a sub 0 directly coordinates with your y-intercept. So highlight a sub 0 and b with the same color. Now, a sub 0 is the 0th term. So it's one before the first term. It's the 0th term. Okay? So we are going to have to backtrack for these problems and figure out what the term would be before the first term that we're given. Okay? And we can figure that out by locating the pattern. Okay? For our problem, what was a sub 0 in the sequence that I just gave you guys with the 5, 10, 15, and 20? It was 0, right? So we're just going to put 0 down here. Okay? So for our problem that we just did, our equation of a sub n would be a sub n equals 5 times n plus 0. Now, the reason this is useful is because if we were asked to find the next few terms in a sequence, it's easy. You just do plus this, plus this, plus this, minus this, minus this, minus this. It's super easy, like we did in the warm-up, right? But what if I asked you, find the 37th term? I don't want you guys going, okay, this is the 6th, the 7th, the 8th, the 9th, calculating all the way up to 37. I just want you to do what? What do you think, Grace?
Multiply the d by 37.
Very good. We're going to say, okay, well, if we want the 37th term, that's the 37th position. So n has to be equal to 37. Okay? And so we're going to do, okay, if n is 37, then this becomes a sub, not n anymore, but 37. So the 37th position is going to be 5 times 37 plus 0. And we don't really need to put that plus 0, right? Because that just means it's being added with nothing. And then 5 times 37, we can do it over here. Oops. 5. We're going to get 35. Put the 3 up here. 5 times 3 is 15 plus 3 is 18, 185. So a sub 37 is 185. Now, right now, I understand this is a little bit intimidating because these are all new variables, right? But once you see the first two examples, a light bulb should go off and it should start to click, okay? So if you're still confused, that's okay, okay? But after the first two examples, if you still have questions, please ask me, okay? Because this lesson, once you see the first few examples, it should start to click. All right, any questions so far? All right, let's keep going. Example 1. It says, write the next 3 terms of the arithmetic sequence But we're also going to write our a sub n formula so we could find any term that we wanted. Nick, what's up? Are you going to answer it? Okay, first things first. Find the pattern. Nick, what's the pattern here? Excellent. So we're going to put -7 between each of the terms. Do we see that? Okay, now we're going to label our terms. What do I label the first term? No, like -7. What is -7? Brady?
It's
A sub 1. What's -14? A sub 2. -21? A sub 4 is -28. Okay, so the three that we're finding are A sub 5, right? A sub 6, and A sub 7. Agreed? What would A sub 5 be? JJ?
-35.
Excellent. -35. We're just subtracting 7 each time. What about A sub 6? -42. And A sub 7?
49.
-49. Perfect. Easy, right? Now comes not necessarily the hard part, but the more challenging part, okay? We're going to write A sub n equals D times n plus A sub 0. You have to memorize this formula, okay? Grace, do you know what D is? Excellent. D is equal to -7. That's our common difference. And does anyone have an idea of what A sub 0 should be? Liz, what do you think it is?
0.
It's 0. Perfect, okay? So we subtracted 7 each time we moved to the right, right? So when we move to the left to get A sub 0, we're going to do what? Add 7, okay? Which would be 0. Yep.
I have an extra Spanish pen.
I do not. I'm sorry.
Borrow one?
I don't have any extra ones. The ones that I have are students that I'm waiting for them to come back for them.
Oh.
Okay? So my final equation is A sub n equals -7 times n plus 0. And I'm not going to put that in there because there's no reason to put in plus 0. Okay? So if I wanted to find the 150th term, I would just plug in n equals 150 and find what A sub 150 is. Cool beans? All right, let's keep going. B. Does anyone notice the pattern here? Gabby, you see it?
Yeah, it's +12.
It's plus 12. So put plus 12, plus 12, plus 12, and then label your terms. What's the first one? A sub 1. Second one? A sub 2, A sub 3, A sub 4. So what we're finding are the next three. So it's going to be A5, A6, and A7. What are they? 36. 48, good. And 60. That was the easy part, okay? Now we're going to say, okay, A sub n has to be equal to the difference times n plus A0. What's my difference in this sequence? Amina?
-12.
Not -12. Remember, the difference is what you did to each term.
Oh, just 12.
Positive 12, okay? So D is equal to positive 12, or just 12. And what's my A sub 0 going to be? Be careful here. Jonathan? Excellent. A sub 0 is going to be -24. Do we see why?
Can you explain?
Can anyone explain why it's -24? Brady? Very good. From A sub 1, we have to move to the left. So we have to subtract 12 from -12. So we're going to get -24, right? Now, as we move to the right, we should always be adding 12 each time. To get from -24 to -12, did we add 12? We sure did, okay? So we keep that consistent common difference, okay? So A sub 0 is -24. So my final equation is a sub n equals, anyone want to try? What'd you get, Val?
Times
12?
12 plus 0 plus 20 negative 24.
Okay, 12 minus 24, but we're missing one thing.
And
N, okay? Should be 12n minus 24. Cool beans?
Gucci Marucci.
Gucci Marucci, let's go. Okay. Any questions on A or B? And now we've got decimals and fractions, the fun part.
Wait, what?
Wait, what? Yes.
You don't have to put that on the test.
It's because I love you guys, okay? All right, so
If you love us, then you
it's not that bad. Okay, 0.2 to 0.6 to 1 to 1.4. What's the pattern here, Alex? 0.4, very good. We're adding 0.4 each time. So, what would my next three terms be? Grace? 1.8, 2.2, and 2.6. Excelente. This was A1, A2, A3, A4, A5, A6, and A7. All right, so my formula is A sub n equals the difference times n plus A0. Is that going to be given to you on your test? Nope, you got to memorize it, okay? What do you guys think the final equation is? Gabby, what do you think it is? Do we agree? Grace, what do you think? It is minus 1/4 each time. This is A1, A2, A3, A4. What would A5 be? Liz? 3. A6, Jonathan?
2 and 3/4.
Excellent, 2 and 3/4. And A7, Val? 2 and 1/2. Ayo. Okay. What would A sub n be equal to? Who wants to try it? Go ahead, Pedro.
A sub n equals 4n plus 4
4n plus 4
1 1/4.
and 1/4? I disagree. Brady?
It's a sub n equals negative 1/4 and plus 1/4.
Plus 1/4?
Or 4 and 1/4.
4 and 1/4. I agree with this one. Pedro, what was the difference between this one and yours? The common difference, right? We are not increasing by a 4 each time. We're decreasing by a 4th. This common difference just needs to get carried over right in front of your n. Okay? Questions on this one?
No.
All right, this was the hardest part of today's lesson. The rest of it is cake. Okay?
Oh, yeah.
All right. You ready?
I love cake.
Any questions on this so far?
It's not that bad except the fraction.
It's not bad at all.
Got confused.
Val, what's up?
I love cake.
You sure?
no.
Ask it.
Can I go get one?
Sure. All right. Graphing an arithmetic sequence. Okay? Now, it looks intimidating because all we're given is a sequence, okay? But all you need to do, okay, is you need to write the position and then the term. What was the first term that we're given? 4. So in position 1, the term is 4. What's the second term that we're given? 8. What's the third term that we're given? 12. What's the fourth term that we're given? 16. So my points become 1, 4, 2, 8, 3, 12, and 4, 16. Let's graph them. 1, 4, 2, 8, and 3, 12. Now, 4, 16 is going to lie outside our graph, so we're not going to put it on there. It's very tempting to draw a line through these points. Do not draw a line through these points, okay? The reason we are not drawing a line through these points is because it's a sequence, right? Do you see how our sequence only includes 4, 8, 12, and 16? If we were to draw a line, we would say our sequence includes all of the points in between there, okay? And it does not. Now, what do you notice about the points when we graphed it? Brady?
So we should draw a line through the points, but not through them, but it's not at the point.
No. Okay? So all this is saying is our sequence only exists at these points.
I'm saying that we need to draw it not through the lines, but stop at the dot.
No. Because the dots are the only part of our graph. If you were to draw, are you saying like draw a line like this, put a circle here, and draw a line like this? No.
Start at the dot and then stop at the other dot.
No, because then everything in between.
No, because that means, I would say that you're saying that everything in between is part of our graph, and we're not saying that. We're saying only our graph includes these dots, because it's a sequence, right? It's only 4 numbers, right? So we should only have 4 dots on our graph. I mean, it continues on forever, right? But it doesn't include all the dots in between them. Gabby?
So like you couldn't put like a dotted line.
Do not put a dotted line. Don't put anything there, okay? What else do we notice about these dots? It's a constant increase, okay? You're going to have a constant increase. What's my common difference here? Hold on 1 second. What's my common difference in this sequence? It's plus 4, right? Guess what my slope between these points is going to be? 4, okay? Make that connection. We went up 4 to the right 1. Do you see that?
Yeah.
So my slope is 4. Do I draw a line through the points though?
No.
No. Okay? What's up, Amina?
So
Okay. So we plot those points. Do not put a line through them. What's our slope going to be just by looking at the sequence? Gabby?
plus
+3. Okay? So our slope should have been +3. If you look at your graph, you will notice each point you rise 3 and you run 1.
so the slope would be
3 over 1. Perfect. Excellent. Moving on. Number C. Letter C.
graphing is much easier than that other.
Peeps. Position 1. 4. Position 2. Position 3. Position 4. Gucci? 1, 4. 2, 2. 3, 0. 4, -2. What's the slope? Negative dose. Is that the common difference? Yeah. All right, and the last one, the decimal one. Position 1 is 1. Position 2, 0.8. Position 3, 0.6. And position 4, 0.4. I know. Okay. At 1, put a dot at 1, so 1, 1. 2, put a dot just underneath 1. At 3, put a dot somewhere in the middle. And at 4, put a dot at approximately 0.4. Hard to see, not that bad though.
Do not
Okay?
draw the line.
Do not draw the line. Very good. What's my slope?
Negative 0.2.
-0.2. Okay? Your slope is -0.2. For all of them? Notice, is there a common difference in the y values?
Yes.
15, 12, 9, and 6. What is the common difference here? Brady? It's not 3. -3. Do you see how we're going down 3 each time? So we would say this is arithmetic because, and you can put one of 2 reasons. You can either say the common difference is -3, or you can say it's in a straight line. Either one of these are perfect explanations. Now, are you supposed to draw the line through all the points? No. Never, ever, ever for these sequences, draw your line. Because that is now saying, okay, we're taking into consideration every point in between those points. And we don't have an equation here, okay? We have a set of terms. We have a sequence. It's completely different, okay? In part B, do you think it's arithmetic or it's not? It's certainly not, okay? Let's check out the difference between the y values. What's the common difference between 2 and 4? So we went up 2. What about 4 and 7? Plus 3. What about 7 and 11? Is that a common difference? No. So we write not arithmetic. And our reasoning is because no common difference. Or what else? What else could we put?
Not a straight line.
It's not a straight line.
We don't draw the line either.
Brooke, why did you sound angry when you said that?